Hello, I am Sameep Singh and I am from NIT Andhra Pradesh, currently pursuing BTech in Electronics and Communication Engineering. I have been selected in SPARC Nano-X Phase 2 program, which is related to semiconductor manufacturing, and it's a 2-week offline program at IIT Hyderabad where I am able to learn various semiconductor manufacturing processes like wafer cleaning, wafer preparation, lithography, sputtering, physical vapor deposition, chemical vapor deposition, etc. etc. And also we have done two projects, that is microfluidics sensor design and waveguide design. So yes, it was a good program.
Hello, my name is Gokul Khatri. I am from NIT Bhopal and I am here for SPARC workshop, which is of 2 weeks duration, and I really got hands-on experience on clean room and machines in the clean room. We work on silicon wafer and we make project on the wafer, and now we give presentation on that.
Farhan Ahmed from Aligarh Muslim University, currently pursuing Bachelor of Technology in Electronics and Communication Engineering. I am here for the 2 weeks at IIT Hyderabad for SPARC workshop on semiconductor manufacturing process. I am here learn about the core lithography and pattern transfer and about the wafer cleaning processes.
Hi, so I am Anup Yadav and I belong to MNIT Jaipur, and currently I am pursuing finally a mechanical engineering student, and I came here IIT Hyderabad under the SPARC workshop. Here we got to know about semiconductor manufacturing processes, and we got to learn about different processes like wafer cleaning, laser writing, and also litho process. So yeah, that's all. So basically in IIT Hyderabad there are basically two types of clean room. One is class of 10,000 and the second one is yellow room class of 1,000.
So now we are entering into the clean room. So let me show you what all precautions we have to take before entering into the clean room. First of all, we will wear the disposable foot cover before entering into the clean room. So after wearing the foot cover, we will now wear the nitrile gloves, mask and the head cover. After wearing the mask, nitrile gloves and head cover, now we will be wearing the bunny suit. Lastly, we will wear the bunny boots and then we will enter into the air shower room. So after entering inside the clean room, first machine we will see the plasma asher machine. It is used to create plasma with the help of nitrogen and oxygen, and with the help of pressure first we will create the vacuum, and then with the help of oxygen we will create the plasma. So now the next machine is we gonna see is the etching machine, which is the Polaris machine. Here we use the fluorine gas for the etching. There are two chambers in this. First one is the load lock chamber and the main chamber. We will put the silicon wafer in the load lock chamber and then it will go into the main chamber for the etching. So now the next equipment we're gonna see is the wafer binder, and it is used to bind the wafers of the silicon. So now we are going to see the sputtering machine. It is a physical vapor deposition type. In this we sputter the ions of various materials from target material and put it on the substrate. The materials can be anything: insulator, dielectrics and conductors. Based on that we will put the DC power supply and the RF bias, and with the help of pressure changes and cryo pumps the ions are getting sputtered. So now the next we're gonna see the electron beam evaporation machine. It is a physical vapor deposition technique that uses a high energy electron beam to heat and evaporate target materials. It can be anything, metals or dielectrics, in a very high vacuum chamber that is less than 10 to the power minus 5 torr to create the thin films. So now as you can see, we are currently using the microscope to observe the substrate at micrometer scale. So now we have entered into the class 1000 clean room, that is also called as yellow room. Here the first machine we see is the mask aligner. It is a critical photolithography tool used in semiconductor manufacturing to precisely align a photo mask with a substrate coated in the photoresist. So after mask aligner we are going to see the laser writer. It is a high precision maskless lithography tool that uses a focused laser beam, often means UV light, which is 405 nanometer, to directly draw, pattern or expose the photoresist on substrates for microfabrication. And after laser writer there is a spin coating which is used to deposit uniform thin films onto flat substrates, usually nanometer or micron thick. And then the hot plate is there, and at the last we see the nitrogen gun also, which is used to dry the substrate.